Okay, so we're going to go over the periodic table test review. So as far as what to study, we took a quiz, and that should be handed back to you by now. I would look at what you did wrong, because you're going to see the same things on the test. And I would take a look at all of your notes from the first through the fourth lesson. Look at all of the bell ringers that I give you. And on your test, you're going to see, it's going to be a typical test. You're going to have the matching at the top, then multiple choice, then applications, and then you're going to have some short answers. So the short answers will kind of look like the quiz. So make sure you know why the trends are occurring the way they are occurring. So let's just get started. So number one, it says a vertical column on the periodic table is called a group. You should know that. We'll go through these quickly. The periodic table was first arranged by the scientist Mendeleev. Okay, and sorry. Okay, the elements in the periodic table are presently arranged in order of increasing what? So if you look, Moseley improved on Mendeleev's periodic table. So they're in order of increasing atomic number. Okay, so they're increasing atomic number, whereas Mendeleev had them as increasing are presently. Yeah, so are presently arranged, they're in increasing atomic. I cannot. Okay, atomic number. Wow. Okay, I cannot talk and spell at the same time, but you guys already knew that. Okay, so it's increasing atomic number presently. Remember, Mendeleev, he arranged them by atomic mass. Okay, so the blank says that when the elements of the periodic table are arranged in order or increasing atomic number, there are periodic patterns in their physical and chemical properties. So if you've watched any of the videos, you'll know that that's the periodic law. Okay, and E, it says all elements in group 17 will have a blank configuration in their outermost energy level. So in group 17, we're going to look, that's 1, 2, 3, I have no idea what that is. All the way to group 17, okay? So the electron configuration that ends in group 17 is P1, P2, P3, P4, so P5. So they'll have a P5 electron configuration. Okay, F, group 1 is also known as the blank metals. So we know that these are the alkali metals, okay? Those are alkali metals. Okay. The two rows in the bottom of the periodic table are also known as so this right here, these two rows, these are known as the F block. Okay. All the elements in group blank have an electron configuration that end in P2. So now we're finding out the group when they give us P2. So this is the whole P block right here. This is P1 and this will be P2. So that's group 14. Okay. The D block elements are also known as this is the D block right here, and these are called transition metals. Okay, the elements in group 12 have a blank electron configuration. So we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the D block. So D1, 2, 3, 4, 5, 6, 7, 8, 9, D10 electron configuration. Okay, an atom with a positive or negative charge is called an blank. It becomes charged when it loses or gains blank. So it's called an ion, an electron. It becomes an ion when it loses or gains electrons. Okay, it never loses or gains protons to get the charge. Okay, electrons. The size of an atom is due mainly to the number of occupied blank that the atom has. So this is energy levels. As you move across a as you move across a period from left to right, the size of an atom will blank. So as you move across, so remember periods are like these all the way. So this is at one period. So as you move from left to right, so from this way to this way, the size of the atom will decrease. Remember, this was a warm-up and it was on your quiz. This is due to the increased number of protons. This was in a warm-up, so you should have had a really good explanation of that. Okay, moving on. As you move down a group, the size of the atoms will blank due to the greater number of blank as you move down the group. So remember, groups are, this right here is a group. Okay, so as you move down the group, the atoms increase, and that's due to increased energy levels. So this whole period has 1 energy level. This whole period has 2 energy levels. This whole one has 3, 4, 5, 6, 7. So as you go down the group, they're increasing in energy levels. So as you go down a group, the size of the atom will increase due to the greater number of energy levels. Okay. The amount of energy required to move the most loosely held electron from an atom is called the blank. That is the first ionization energy. So basically, the energy required to make it an atom, the energy required to make it an ion. So that's what this means, basically. So the amount of energy required to move the most loosely held electron from an atom, that's basically making it an ion. So that's the first ionization energy. P, the amount of energy required to move a second or third electron from an atom is always more. Okay, because once you remove one, that positive, there's more positive charge than negative. So it's being held on tighter as you pull electrons away. Then the amount of energy required to remove the first electron. All right, so for potassium, we would expect a large increase in ionization energy to occur when the blank electron is removed. This is because potassium will have the same electron configuration as blank before that electron is removed. So let's look at potassium. Okay, so here's potassium right here. Okay, so the first electron that you take away, it's going to become, so these all have 1 electron, valence electron, but once you take it away, it's going to become like argon. Okay, so it'll become isoelectronic with argon. So remember that word isoelectronic. You're going to see it all year, if I can spell it. Okay, so you're going to see isoelectronic all year. It just means that it has the same number of electrons as something else. So, for example, potassium, if you take an electron away, it's going to become isoelectronic with argon. That doesn't mean it becomes argon, because it still has, argon has 18 protons, and potassium will always have 19 protons. Okay, so that will always be, it will never change. But you can change the electron configuration or the electron numbers that it has, and that happens when bonding occurs. And so to become more stable, because you don't see just potassium alone in its ionic, in its positive state, because it's not stable. It has this 1 electron on the outside in its energy level, and it needs to get rid of it. So for potassium, we would expect a large increase in ionization energy to occur when the okay, I'm sorry, I didn't answer your question. So you take away 1 electron, and it becomes like argon. So it doesn't take much energy to become like one of the most stable elements on the periodic table. However, you're trying to take, so that's the first ionization energy, it becomes like argon. The second ionization energy would be to take the electron from the electron configuration of argon and take another one away, so it has 17 electrons, to become isoelectronic with chlorine. That's going to be where the biggest jump happens. So it's the second ionization energy. So from potassium to argon, that's first ionization energy. And then argon to chlorine, that's the second ionization energy, and that's going to be a huge jump. Sorry, I didn't read the question completely before I started answering. So when the second electron is removed, this is because potassium will have the same electron configuration as argon, which is a noble gas. Once they have the same electron configuration as a noble gas, it takes a lot of energy to remove an electron from a noble gas configuration. Okay, ionization energy will increase as you move blank and decrease as you move blank. So ionization energy, that's just a trend we're talking about. The trend would be as you go across the periodic table, the ionization energy will increase. As you go, as you move across, as you move across the periodic table, ionization energy actually will increase, okay, as you go across, and that's because fluorine, it's due to its electronegativity, which means that it's able to pull the protons in here, will be pulling those electrons towards itself, so it's going to take more energy to pluck them away. If that makes sense. We'll talk about that in class if it doesn't, but ionization energy, basically the energy it takes for one of these elements to become an ion. That's what that means. So the trend is it increases. It's more difficult to pluck the electrons away as you go to the right. And then as you go down, it actually becomes easier. So the ionization energy will decrease as you go down the group. It makes it easier to pull an electron off, and that's simply because of the amount of energy levels that they have, making the electrons further away from the nucleus, making it easier to pull those outer electrons off. And we will probably, by the time you watch this, we will probably have done a warm-up on that. Okay, so ionization energy will increase as you move across the periodic table. I don't know if it wants us to say that, the periodic table, and decrease as you move down the periodic table. Okay, maybe down a group, I don't know. There we go. Okay, so the size of a positive ion is always blank than the size of a neutral atom from which it was made. So remember, cations, that's a positive ion, and positive ions are always smaller. Okay, and if you think about it, the cation, that means there are more protons than there are electrons. So the electrons will be pulled in more tightly towards those protons. So keep that in mind. Cations are smaller. You can make some kind of acronym if you want to remember that cations are smaller than the neutral atom, and the size of a negative atom is, negative ion is always larger. If you need to review that, that's on the last video that we made not together, but the last video you watched. Okay, fluorine has the highest electronegativity with a value of blank. So this value is 4.0. That's the highest electronegativity value that we have. Electronegativity is the ability of an atom to attract electrons towards itself when the atom is in a bond, a chemical bond. Okay, and keep in mind we really don't have values for the noble gases. If you remember on your video that I made, they didn't really have electronegativity values for the noble gases. Remember, that's when it's in a chemical bond. We measure that when it's in a chemical bond. And these guys, keep in mind they are super stable and they don't bond with anyone unless we make them. So that's why we don't really consider them. That's why at the top right is the most electronegative one, and that's because fluorine does make bonds, however the noble gases don't. Okay, W, the electronegativity will blank as you move down a group, so it decreases as you move down a group, and the elements in group blank do not have defined values for electronegativity, and that's what I literally just told you, group 18, which is the noble gases. Noble gases. I don't know. Okay. Electronegativity will blank as you move across the period, and it will increase. Okay. Okay, so now we're just going to kind of, you'll see a lot of these on your test, and I remember the kids it's so easy to get this mixed up. Smaller, larger for atomic size, ionization energy. So a lot of what we learned are those trends. There are 3 trends: electronegativity, and remember, that's the ability to pull electrons towards itself when bonded with something else. Ionization energy. That's how much energy it takes to become an ion. And then atomic size. So basically these two, the trends are the same, okay? So for both of these two, as you go down, it will as you go down, it decreases, and as you go across, it increases. So basically let's say that's the periodic table. So on the periodic table, this is the highest one and this is the lowest one. Okay. So this would be highest electronegativity, lowest electronegativity, highest ionization energy, lowest ionization energy. So this goes for both. Atomic size is basically the opposite of these. So however you want to kind of get this straight, you will be using these trends to answer these questions on the test. So make sure you have them down, and we're going to go over these in class. We'll play games, we'll review, we'll have, what's it called? Sorry. We'll have warm-ups and activities. So by the time you take the test, you should have these straight, but if for some reason you were gone, you're on some kind of athletic trip, make sure you have these 3 trends down because you will be answering questions like these. And if you don't know these will be hard to answer. So circle the atom with the larger atomic size. So remember let's look at not such a messy one because I have destroyed it. Okay. So atomic size, so remember atomic size, let's see, as you go this way it decreases. We'll just do AS, atomic size. And then electronegativity increases. And so does ionization energy. Okay. All right. And then the same trend is for going down a group. So going down a group, as you go down the group, atomic size increases, but electronegativity decreases and ionization energy decreases. Honestly, guys, getting these straight is the most difficult thing on this test. Honestly, the test is about these 3 trends. Okay. So anyways, circle the atom with the larger atomic size. So last year, some of the kids got confused thinking this is like a multiple choice and they would just circle one. Keep in mind you are looking at each set of elements and deciding which one is larger or smaller or has a higher electronegativity or ionization energy. So first we're going to look at magnesium or calcium. So we have magnesium and calcium. We're going to compare magnesium and calcium. So we're comparing atomic size, and the larger one. So atomic size increases as you go down, so calcium is actually going to be larger. So we circle calcium. Okay. We have to compare gallium or bromine. So gallium or bromine. I am on the wrong side, sorry. Okay, so we are still looking at atomic size and we want the larger one. So remember, it gets smaller. Atomic size decreases as you go to the right because you increase the number of protons. So gallium is going to be larger. Okay, so that's it. You have nitrogen or arsenic. Okay, atomic size increases as you go down because you're adding energy levels. So arsenic is going to be bigger. Okay, and then rubidium or strontium right here. Okay, or this one. It decreases as you go to the right, so rubidium's bigger. Okay, so the test looks just like this. Most of your points are going to be this, and then kind of at the end you're going to explain why the trends are the way they are. And remember, it's going to be either increasing number of protons or it's going to be increasing number of energy levels. So just get them straight, and then you've got the test made. It's super simple. All right, number 3. Circle that atom. Circle that atom with the smaller atomic size. So now we're doing atomic size still, but we want smaller. So vanadium or manganese. So vanadium or manganese. Okay. And now we want smaller. So remember, they get smaller as you go to the right, so we're looking for manganese. Okay. SN or SI. SI or SN. Okay, so the atomic size gets bigger as you go down, so 10 is going to be bigger. Oh, wait. We want smaller. Okay, so Si or 10, so silicon's actually smaller. This literally is the most confusing part of the test, is just getting it right in your mind. Okay, smaller atomic size, nitrogen or fluorine. Okay, they get smaller as you go to the right, so fluorine's smaller. Rubidium or strontium again. We're comparing these two. And we want smaller. They get smaller as you go to the right, so strontium is SR. Okay. Circle the atom with the larger first ionization energy. So I noticed some of you guys struggling with this concept with the larger first ionization energy. So you have P or S. So we're looking at these two, P and S, we're comparing. So ionization energy increases as you go to the right. So P and S, is it larger? Larger. So increases as you go to the right. So sulfur would have the largest first ionization energy. Now we're going to look at aluminum or chlorine. Do we want to change colors of pens? Might help, I don't know. Okay. What are we looking at? Aluminum or chlorine, larger first ionization energy. So we have aluminum and chlorine. Okay, so remember, ionization energy increases as you go to the right. We're looking for the larger one, so chlorine. That's going to bother me if I start a different color. Okay, then potassium or lithium. So we have, oh, they're over here. We have potassium or lithium. Okay, so ionization energy decreases as you go down. So the larger one will be lithium. And oxygen. Oxygen. Tellurium, however you say it. I don't really do much with that. Ionization energy, it decreases as you go down. The only thing that increases as you go down is atomic size. So we are comparing oxygen or beryllium. So oxygen will be the largest first ionization energy. And again, you guys don't have to know how much energy it takes. I just gave you an example on your notes, but don't think you have to know how much energy it takes to ionize oxygen. You don't have to have that memorized. You just need to know the trend on the periodic table. Okay, and then circle the atom or ion that is larger. So now we're not really looking at trends on the periodic table. We are looking at, is it a cation, is it an anion, and we're comparing it with the neutral part of the atom. So Remember that anions are larger. However you want to remember this. Anions are larger and cations are smaller. Okay, so anions are larger, so it's wanting us to circle the larger one. So anions are larger. Cations are smaller. So if we want to circle the larger one, if you're looking at a +2 or a +3, you're going to want to circle the one with the least positive charge. Okay, I know that it's getting kind of crazy, but it's okay. Magnesium, so this is a +2 charge. We're looking at the one that's larger, so cations are smaller, so we're going to circle the neutral atom. Here, we have a -1 and a -3. So we're wanting the larger one, so whichever one is more negative is the larger one, okay? So if you're comparing positives to positives, and it's wanting larger, look at the one with the least positive, okay? If you know this right here, all you have to do is think a little bit and you'll be able to answer these types of questions. But honestly, the test is mostly this. So make sure you have these trends and these trends down. That's the most difficult part in my opinion. Everything else is just applying those trends. Okay, circle the atom with the larger electronegativity. So now we are back to the periodic table. Let's see, larger electronegativity, boron or indium, which is right here. We have boron and indium. So electronegativity increases as you go to the right and decreases as you go down. So the trend we're looking at, I already forgot, so sorry, boron or indium. So it is decreasing as you go down. So it wants us to circle the larger one. So boron is larger. Okay, rubidium or cesium. Rubidium or cesium, so here or here. Electronegativity decreases as you go down. It wants the larger one, so rubidium is the larger one. Carbon or fluorine. Carbon compared to fluorine. It increases as you go to the right, so fluorine is obviously more to the right, but fluorine has the highest electronegativity with electronegativity of 4.0. Okay, you may want to know that for the test. And then tin or antimony. So tin or antimony. It increases as you go to the right, so antimony would have the higher electronegativity. Okay, so does lithium or fluoride have the highest, fluorine, have the larger atomic radius? Explain why. So basically this is exactly like your quiz, except I'm giving you two choices. You choose which one is the larger atomic radius, and then you tell me why, the same way you told me on the quiz. So lithium or fluorine. Here's lithium. And fluorine is all the way over here in the same period, but all the way. So we already know fluorine has higher, atomic radius. So atomic radius, they get smaller as you go to the right and bigger as you go down. So larger one, so lithium is larger. Because it has less protons than fluorine. So lithium's nuclear charge does not have as strong of a pull on those electrons. So because lithium has less protons, it's not pulling those electrons in as much. Okay, moving on, we're almost done. Arrange the following elements as described below in order of decreasing atomic size. So keep in mind on the test, I'm never going to give you something diagonal, okay? It's either going to be in the same group or the same period. So for A, in the same period, we're looking at atomic size. Decreasing atomic size, so biggest to smallest. So CFO. So here, here and here, CFO. It wants decreasing atomic size, and remember atomic size decreases as you go to the right, so we would want it to be COF would be the answer. Decreasing atomic size in the period. And then down a group, so down a group, they get bigger as you go down. So KLI or cesium. So we have KLI and cesium, so they're all in the same group. And as you go down, so it wants decreasing atomic size. So that means they're getting smaller as you go up. That's tricky. So it increases as you go down, so we want to go up. So we have cesium, and then potassium, and then lithium will be our answer. That was a mean question. Now it wants us to arrange the same things in order of increasing ionization energy. So basically, if atomic size was one thing, the ionization energy will basically be the opposite. However, we had to do it in decreasing atomic size. So increasing atomic size, it actually should be COF if it's increasing ionization energy. So as you go from left to right, ionization energy increases. So basically, we just have to put those in order of increasing, which is COF, COF. And in the group cesium, potassium, lithium, we're putting them increasing ionization energy. So cesium, potassium, lithium. Ionization energy actually increases, ionization energy actually decreases as you go down. So, and it wants it in increasing order. So we basically, it's the same order. CSKLI. It looks like it's the same, but keep in mind it's asking for an opposite order, okay? If it would have said decreasing ionization energy, these would have been flipped backwards. Okay, in order of decreasing electronegativity. So decreasing electronegativity, remember electronegativity increases as you go from left to right, increase electronegativity. And we're looking at carbon, oxygen, fluorine. So as we go to the right, is it asking for increasing? Decreasing. So we need to go, for it to be decreasing, we need to go this way. So FOC would be our answer here, FOC. Have you guys noticed that every single question has been based off of the trends that you should know on the periodic table? So really know those trends, guys. That's what's gonna save you on this test. Okay, and then electronegativity, again, is probably going to be opposite, but we're doing decreasing electronegativity for cesium, potassium, and lithium. As you go down the group, electronegativity will decrease. So it's asking for decreasing. So basically, we're going to say lithium, potassium, and cesium. That's it. Okay. Now this one. So this is ionization energy, and it's asking for us to, among the following pairs of atoms, identify the larger of the two, the one that requires the most ionization energy and the one with the lower electronegativity. So basically, again, we're doing those trends. It just looks like a different question. I'm trying to get as much practice in on those trends for you as I can. So basically, which one's larger, lithium or potassium? So you just look here, which one's larger, lithium or potassium? They get bigger as you go down, so potassium's larger. Okay, greater ionization energy. So ionization energy actually decreases as you go down. So lithium will have greater ionization energy and lower electronegativity. So electronegativity also decreases as you go down. So potassium will have the lower electronegativity. So we're just going to do that for the others, and I'm going to do it a little more quickly. Which one's bigger, carbon or nitrogen? We have carbon, nitrogen. They get smaller as you go to the right, so carbon's bigger. Greater ionization energy. Ionization energy increases as you go to the right. So nitrogen will be the greater one. Lower electronegativity will be the other one because electronegativity also increases as you go to the right. And it's asking for lower electronegativity, so it's C. Okay. Magnesium or calcium. Which one's bigger? So magnesium is here, calcium is here. They get bigger as you go down, so calcium's bigger. Greater ionization energy. Ionization energy decreases as you go down. So greater ionization energy would be magnesium. Lower electronegativity. So electronegativity also decreases as you go down. So lower electronegativity, that'll be calcium. So again, just know those trends. Oxygen or sulfur. Oxygen or sulfur. We can do this. Okay. Size decreases as you go to the right. Oxygen, sulfur. Oh, we're going down the group. Okay. So size increases as you go down. So sulfur is bigger. And then oxygen, sulfur. Greater ionization energy. Ionization energy decreases as you go down. So oxygen will have the greater ionization energy. Electronegativity also decreases as you go down. So lower electronegativity, that would be sulfur. Really look at what I'm asking for on the test. Very easy to get confused. Okay. The outermost energy level configurations of the theoretical elements A through E are listed below. Label what element the electron configuration corresponds to. So let's just look outermost energy level theoretical elements A through E. Okay, so this has something you don't know. This is the energy level or period number, okay? So number 1, energy level 1, energy level 2, energy level 3, 4, 5, 6, 7, okay? That's what these numbers represent. All right, so 3s2. So 1, 2, 3, that's what the first number represents. And you guys know that these are all S1 and these are all S2. So 3s2 would be magnesium, okay? 3s1, so again, we're in 3. S1 is here, so that's sodium. Okay, 2s2 and 2p6. So we have 2s2 and then 2p6, which would be neon. Okay, so 2p6 would be neon. You're not going to see this on the test, just now that I think about it. But I'll go ahead and you're going to see it on the next unit, so unless you're just exhausted, you can, I guess, stop it. Actually, you want to know this one too. 2s2, 2p5. So 2s2, and then 2p5, which is fluorine. And then 2s2 and 2p3. So 2s2, and then 2p1, 2, 3. So that's nitrogen. Okay. I'm sorry. I had them do that on last year. Anyways, that's okay. Explain why elements with high ionization energies typically also have high electronegativity values. So I would explain it by saying that these elements do not want to lose electrons because they wish to obtain the same electron configuration as the noble gases elements on the right side of the periodic table, they are the ones that behave this way. So explain why elements with high ionization energies typically also have high electronegativity values. So basically, once you're isoelectronic with a noble gas, one of these guys who are very stable, it's going to require a lot of energy to take them out of that noble gas state. Okay. All right, so hopefully that helped. If you have any questions, post them on the questions forum and I can kind of address those.